It's shorter people.
But if you are a short person.
You. It's Thursday.
Not yet?
Today's Wednesday. You said tomorrow. Yeah, you did.
There's three.
Pretty sure. Pretty
I just hit my head.
All right, ladies and gents, let's take attendance here. Landon, Tommy, Coy, Michael, Andrew, Keegan, Owen, Dylan, Josh, Cole, Nathan, Nick, Caden, Taylor, Aiden, Jake, Matthew, and Brady. Awesome. 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 All right. So yesterday I told you, give you the start of class to finish up those calculations. We did the lab outside yesterday. Hopefully you still have all your sheets. All right. Now, what you will notice is we're basically using the exact same equations in all of these problems, right? Right? That's the equation you're going to be using in all, I think, almost all these experiments. All right? You don't think you'll be using that one? Don't think you'll be using that one. So, yeah. All right. You guys can get in your lab groups. If you guys have any questions on the math part of it, let me know. I will crush this probably in about 15 minutes. 10 minutes. That's. Oh, the riddle?
Yeah. No.
Ooh. Yeah. Is it your nose? It's your nose.
Oh.
It is your nose. Wow.
Actually, on my hand.
What if you're also blind?
I still like to answer short people better.
Then you're overlooking everything.
Then you're still at least overlooking your nose.
But
You're not looking at your nose.
What if?
Well, you can.
Have you seen the movie Waterboy?
Yeah.
What about that guy that's always
Everybody-
looking like this? Always has his eyes on his nose. Yeah. What about him?
But his eyes are still overlooking the nose.
I feel like when trying to poke holes in this logic, I feel like the easiest thing is just, what if they don't have it?
He's got a point. I mean,
Yeah.
well, he doesn't have.
Yeah, or like, what if he's blind?
If you met a person that doesn't have a nose,
Voldemort.
Voldemort still has like a nostril.
There are certain people, like, you know.
I think everybody's overthinking.
That's the point of this class.
Yeah, exactly.
All right.
Well, that's basically every animal.
I mean,
so get out the lab. Try to get this done. Anybody need a calculator for the day? You? Come up here. All right.
I really just need to remember to get it out of my locker.
If you guys have any questions, please let me know. Then we're gonna move on. I'm gonna pass out some papers. All right. I don't think I have a whole lot. All right.
So, mine was 11 centimeters, and yours is 1.
I've been trying to grade these, but yesterday was so nice outside. I'm like, nope.
Yeah.
You wanna go play this off? Yeah. But I did.
What's funny is my ninth grade science teacher also did an install. You guys look very similar. This was in camera.
Oh, I was like, wow. Yeah. Love playing this off. Hey, you were out.
I don't think I did. They took us outside.
We're like around the answers that I should be getting for the overall.
Say that one more time.
What are like, what's like a decent like range of possible correct answers you're throwing out? So I'm like mid to high 30s, low 40s.
For velocity?
Oh,
Oh, yeah. For a tennis ball, that's average.
Alright, just wanted to make
If
sure.
it was like a baseball, it'd be a little higher.
Yeah,
say
I was like, that
probably
seems
low
a little
50s.
slow because I'm used to.
Yeah.
That's it. It's finding displacement from when. That's where it started. Do you have a choice there? Probably.
That's fine.
That's right.
This is like my one opportunity for bonus. Oh, that was my second positive.
What was this one?
It's at the very bottom. You had to solve something on that video lab.
Oh, I thought it was the other one.
Oh, the second one's on this. Whoever gets the closest to the number, closest height of the ceiling.
I did the
It's
one.
bonus.
279, actually wrong, but I did the one.
That is.
How many? I don't know. Whoever's closest gets you.
Oh, yeah.
So there's two siblings.
I
Sure. I should have one.
Okay, wait, I didn't see the
Right there.
So.
That's kind of weak. The neighbor, it's like double.
It says.
6.5 centimeters.
I need to materials to measure.
I went from like
Doing the right thing.
Yeah. Gotcha.
I did it all right, all the right stuff, all the right way, and I was like, that doesn't seem right. So I did this like super roundabout way, and I also got it right, and I was like, that's like the same thing as the first one. Oh, I did the same thing.
Wow, we messed up.
According to them, too.
This is the place.
2.54. That means it's 2.5 meters, which is not
The worst place to work.
the height of the ceiling.
So that was your double.
Yeah.
Centimeters.
So that, yes,
Yeah.
Well.
So you would have to convert that to.
yeah.
Yeah, maybe. Oh, yeah, maybe more.
Alright.
Yeah.
So change. Change. So that's double. Right?
Yeah.
Yeah, that's but on the negative.
So it'd be negative.
Oh,
Drop it.
Okay, work, yeah.
yeah, his reaction time.
Let's try your final.
Let's figure out the.
I said,
Does that be meters?
negative, that's why.
Shouldn't
Oh,
emphasize
You got
Maybe
0.15.
do that.
So you already have to get,
So you got
150.
maybe like, so the.
Okay,
maybe
only
minus
now.
that, put a little force on it.
Okay. I guess will be 0, and then the initial. Oh, you're falling down. So when you're going down, it'd be negative. I just had to see it. So negative 0.173.
So that's another source of error.
Oh, your reaction time.
Like your reaction time.
How
are you?
Almost
Well, I'm not that old.
That's a pretty quick reaction, but it's doable. Yeah.
Yeah. So it's
That's what the data said. You were pretty solid. I knew you were
I think we were like 20 centimeters up. So it was 274 centimeters?
Yep.
Our name on the paper we did.
As long as you're logging in. Yes.
So your reaction time is 0.15 seconds. Owen's reaction time is 0.7 seconds. Mine is 0.1.
Last week we did really good. So there might be a chance it gets bigger. And then my third option,
I think I'll try to check
What
one out.
activity are you doing?
The first one I like really did all out. The second one,
this guy's
So your initial velocity was 0.
but
So 0 times t is just 0, right?
on a team,
Have
they have
the acceleration. So it might be half your time.
they got so now he may get in.
I'm gonna be honest, because if you do the whole time.
It's total.
Then it would be like, that's the one you roll. xny-phje-irt. I'm not going for that.
Yeah.
You're trying to find. Don't
In
have
no PPR, you only
so that when you have the time, that's really going to affect your
valuable and then
find on this formula sheet. First three equations are all just different variations. So like use this equation, solve, use your normal time, and then
you guys got.
Yeah, the third one.
No.
Here, 4.2 seconds. I was like, holy, what the science?
2.7.
That's pretty good. I was like, that is insane.
I just realized so.
Yeah, prior to that.
So we're using this formula, that's how. How do we? How do we get that? If we're trying to answer. So use Andrew's.
So what is the rubber total time, correct?
My time.
Yeah, I don't know. But a rubber band. Yeah, it doesn't have to do nothing. And we actually work on it.
So we're solving for.
But I didn't make
Always.
Easy.
Get like 0.7.
Would be major. So when using this. The displacement.
I want to make sure I'm looking at that.
20 centimeters. I thought like dropping it like this, like not dropping it straight.
Pushed it or whatever else.
Yeah. That's a normal. It's reasonable.
I'm like top.
Yes.
That's 3 meters. That's crazy. Can I jump 3 meters high?
That is pretty high. That's the.
So would that be like?
Pretty.
Everyone wanna know how high they jump?
Sure, you can do it.
Okay, I jump 35 inches. Oh, you jump 37 inches.
Yeah, I mean,
Wait, that's.
Easy. Super easy.
What's the actual?
It's 2.74 meters.
You actually jump 51. I anticipated jump 30.
You got half of that? All right.
That's what. Oh, that's such a hard
Did you measure yourself and subtract that? Whether they're young, it's just when you get around. So if you're able to.
Yes. Done? Awesome. Thank you.
But that is, it's not taking into like that, because you pick up there.
We also.
Just do it.
You're right there. I mean,
It's hard.
Yes.
We have a rubber band.
Yep. Give me a second.
I jumped.
Okay, so, the 3 meters was for, Ryan and Andrew. Me and Josh's was 4.8 meters, which means we could jump and be standing on top of a basketball rim.
It's pretty impressive, honestly.
So,
Just a little tiny higher.
something little. It was probably because like we landed on top of like straight like this. To keep our legs up as long as possible.
Yeah.
So that's probably the Josh, can you jump and like land on top of that one?
First one today. All right, you ready?
It's rubber band.
Yeah, but what's happening?
I catch it.
Okay.
So this is my Adam.
Alright. Yeah.
What happens? I tie tunnels with the door. Come back here.
Am I supposed to follow you?
No, like, you're good.
You're gonna let it go?
No.
So what you do is, so this is like my orbital, right? Have you been in chemistry?
Yeah.
Or are you in chemistry right now?
No.
Alright, so this is like your orbital, right?
Yeah.
Now, as you start gaining more and more protons going across the periodic table, what you start to do is you start to stretch in a little bit, right? So the atomic size actually decreases. I get some more. I got a little bit smaller, right? It gets a little tighter. Don't let go on me.
Oh.
I'm just kidding. But so it's kind of like a visual I like to do. What I usually do is I tie it up here and then I tie it on my sink. Guess for a rubber band. Thank you.
I've been cow hunting for a little bit now.
All right. I'll get you out. Big, small, big. It doesn't matter.
I'll return it later.
Oh, that was a bad toss. This is my left hand. All right. How you guys doing? Almost done? All right. If you guys are done, I will give you the end of this chapter's homework. Okay. Now, I'm giving it to you now. There are what? 11 plus. 11 plus.
Yeah, it's going to
12, 23 problems. However, I'm not collecting this until Monday. Okay, so you have Wednesday, Thursday, Friday, Saturday, Sunday, Monday. You have 6 days to do it.
So what you mean is we're all gonna cram it until Sunday?
Yeah.
Okay.
All right.
Glad we're on.
This would be good review for tomorrow's quiz, at least the first page. The second page, we haven't discussed that stuff yet. It's graphing acceleration. But I am going to pass this out just so you have it. Quiz over those 3 equations.
If you get the equation sheet, you should.
Yeah, I'm like, what? I forgot about the.
You don't have the equation sheet? Oh, you do? Okay.
I think, yep, I do.
I was going to say, if you don't have the equation sheet, it might be a little rough. So I am going to pass this out so you have it. If you're done with the lab, you can get started on this.
You guys are.
Is it ours? Yes, top 3. Top 3. Yeah.
Actually. Oh, you're good, because he said that was a smart thing, so you're just about it.
Due Monday. Plenty of time.
They're not.
Plenty of time to get this done.
They are not.
About 1,250.
Yeah, chapter 3 is very, very short. Probably Friday or Monday. It's just graphing after this. The free fall, I'm gonna skip a decent amount of it, honestly. It is the same equation, same 3 equations as 3 acceleration graphs.
No. No.
All right, did everybody get the homework? All right, sweet. Called it that little folder technique again. I like it.
You don't need to staple, Owen, don't give me that.
He just stapled.
Well,
What? Is that okay?
we're just, no, it's whatever.
Just making sure they're stapled.
Defeats the purpose of holding.
When does Cole get back?
Yeah.
I don't know when Cole's coming back.
Me neither.
It's not the same about me.
Yeah.
Oh, is that mine?
No, it's not yours.
All right. Is there any questions on the lab? Do you get a homework, Peter?
I don't.
Did. My bad. I went around the circle. I just didn't hit the heart of the circle. Yes.
question number 4, as truck travels east with increasing velocity.
Oh, yeah, we gotta finish the goat videos.
Yeah, go
Cars,
for
that the truck travels east.
All right. We finished the go video.
No,
we only watched- no, we didn't.
we saw the baby almost falling.
No, I just stayed in here for a few minutes.
I also did the same.
All right.
I'll put my desk back where it was.
So,
Because it was not.
you guys done with class?
No.
All right. As you guys see, free fall uses the same equations, all right, as we've been talking about. Now, in our guided notes, I am not going to go over all the free fall. All right, there's just a lot of practice problems. I'm not going to go over all of them. You want to know why? It's the same 3 equations we've been talking about. All right, it's the same exact 3. All right, the power 3. All right, I am going to go over a few of them today, just to give you guys some practice for tomorrow's quiz. We do have a quiz tomorrow. Okay. You guys will crush it. I know it. You guys crushed the first one. You'll crush this one. And then after today, we're going to move on from free fall and do graphing. All right. Graphing is pretty straightforward. You'll see what I mean when we get there. All right. So I think I was working on example number 26, and I was like halfway through, and like the bell rang. I kind of lost track of time that day. It's kind of like time flies when you're having fun. Time flies when you're having physics.
I don't think time really flies.
Yeah.
You can't.
According to physics, time can fly. All right.
Time is a construct.
So I think, oh, I did not want that to happen. There we go. It'd probably help if I turned on my projector so you can see what I was doing.
No, that's.
No?
We cannot.
But then we won't be able to see the Go video.
We know what you mean, though.
No.
You know about the Go video?
No.
You don't know about the Go video?
We just gotta listen, they don't need the video.
No, I'm.
Oh, you definitely have to see the video. All right. So, going to go over a few practice here. All right, I think I got, let me zoom in a little bit. Oh, come on. There we go. Is it?
Do you hear that?
That's what it usually sounds like.
I just because I'm driving on it today.
All right, so I literally got that far on the problem. All right, I can zoom in a little bit, make that larger here. All right, so where was I? Let's see. Negative 380 equals 0 plus half A. What is A? What's the acceleration? Negative 9.8 meters per second squared. Every time. Every time. All right. And let's see. The time squared. Oh, that's what I'm trying to solve for, right? Okay. So from here, I'm going to rewrite it. Negative 380 is equal to the half of 9.8 is negative 4.9 t squared. Right? From there, all you got to do is divide the negative 4.9 over. And I got, let me see, 77.55.
Wouldn't it be 78?
You only do sig figs at the very, very end. Like your answer is your sig fig. All right. That's a great question. Equals t squared. Take the square root of that. Take the square root of that. And I'm going to have 2 sig figs, so 8.8 seconds. 8.8 seconds. I kind of ran out of space. Does that make sense on that one? I know I kind of cut it in half there. All right. How fast is the penny going when it reaches the ground? So now I know x is still negative 380 meters. Acceleration is always negative 9.8 meters per second squared. My initial velocity was 0. I know the time now was 8.8 seconds. What? I'm trying to find final. Okay, so I'm looking at my equation sheet. Looking at my equation sheet here. Let me zoom in a little bit. What equation am I going to look for if I'm trying to solve for final? Could I use my first equation? I very well could. All right. Final velocity, initial velocity plus acceleration times time. I could use that. Could I use my second equation? Do I know my displacement? Do I know my initial velocity? Yeah. Do I know my time? Do I know acceleration? Do I know time? But this doesn't have the final velocity. So, okay, can't use that one. This one, I have everything I need. Final velocity squared equals initial velocity squared plus 2a times the displacement. Which one's easier? Yeah, for sure. I could use this guy, right? I have everything there, but the first one's a lot shorter. Let's do that one. So my Vx, my V final, is equal to my V initial plus a times t. So here's the equation I'm going to use. Plug it in. Plug in your numbers. Get the answer. All right. Anybody get an answer? Yeah, what you got, Tom?
86 meters per second.
That is exactly correct.
Wait, negative.
Is it negative? How fast?
No.
It should be positive. Yeah, it should still be positive.
Yeah, it's a mix.
I think it's just speed.
Just speed.
Well, it's still velocity. So if you plug in velocity final, so velocity initial, so acceleration times time. So acceleration.
By the way, the acceleration is negative.
Acceleration is negative. Yeah, so it's negative. It's still negative. You're correct. I just didn't plug it in. So yeah, acceleration is negative, time. Beautiful. Any questions on that one? All right, we're gonna go over one more example. One more, and then we're gonna move on. Sound good? All right, next one. Example number 27. Harry is on top of the Empire State Building, 380 meters. All right, so I know my displacement is 380 meters. Or, well, that's how high the building is. I won't write that down yet. And decides to throw his penny down with a velocity of 5 meters per second. So I know my initial velocity is 5 meters per second. Well, actually, he throws it down, which means negative 5 meters per second. Negative 5 meters per second. All right. He makes a wish too. What is his velocity 2 seconds later? All right, so I know my time. Time is what? 2 seconds. Very good. I always know my acceleration. All right. And what is the velocity? So what is my final velocity? All right. So which equation am I going to use? I have my initial, acceleration, time, and final. Well, there's my final, there's my initial, acceleration, time. I can just use the first one, right? let's use that. I like using my first equation. All right, so V final is equal to V initial times time, or what am I writing down? V initial plus AT. So -5 plus -9.8 times the time. When you plug that in, what do you guys get?
My statistics might be wrong, but it's negative 25 meters per second. That is correct.
So what I got, you are correct. And the reason why, all right, the reason why, well, do you say negative 25? Yes, okay. When you multiply these two numbers together, all right, you're going to get negative 19.6. However, when you add or subtract, you have remember the rule for sig figs, you're going to take the decimal with the least. So this has the least number of decimal places, right? So when you add these two negatives together, you're going to get negative 24.6. Now, I had to draw a line there, and I have to see if this rounds up or down, correct? 6 rounds up. So that's why you get negative 25. Does that kind of make sense? So that's the velocity, meters per second. All right. Now, how much has it fallen in those 2 seconds? So now I have to solve for x. Okay. How much has it fallen? Okay. I know all of these things, but now I have to solve for x. All right. So I'm probably going to use my x equation.
Why couldn't we do a third one? Because it already has.
Third one?
Yeah, because it already has a displacement already.
Velocity final, velocity initial, 2a. You could.
Because wouldn't that be easier since it's already delta x and it'd be easier to move that stuff inside?
If you would like. Yeah.
Sorry, that was just a question if we could use that.
Oh, yeah, for sure. That's up to you. I like using the middle equation as often as I can because it just makes sense to me. But yeah, if you like that third equation and you have all those numbers, totally. So delta x is equal to velocity initial times time plus half the acceleration time squared. Okay. So my initial velocity is -5. My time is 2 plus half my acceleration time squared. 2 squared, 4. And you plug that in the calculator. All right. Okay.
Would be negative 9.6.
You say negative 9.6 as the answer?
Yes. Well, not including sig.
Different answer. I'm going to check real quick. So I combine 5 times 2 is -10 plus I got 0.5 times -9.8 times 4 plus a -19.6.
I think I calculated just.
So if you do a -10 plus a -19.6, I got -20, -29.6.
Then you would also make it 30, right?
To sig figs, yes. -30.
30 point. Oh, I see what I did wrong, wouldn't it?
Well, just -30.
I forgot to be subtracting this 5 instead of adding.
Yeah, you could add a point if you want to.
There we go.
You got it? All right. So -30. My unit is meters. Does that kind of make sense? Yeah.
Do you have to add the point or not? Because doesn't it end up changing how many sig figs?
When adding or subtracting, you don't have to in that case because you're doing the least number of decimal places. So in that case, it doesn't matter. That's a great question. Yes.
So you had -19.6, which is just the 1/2 times -9.8, so then.
Times 4.
So also-
Say what?
Oh, I was thinking times 2 instead of times 1/2, and that just, yeah, the numbers were weird to me that time, sorry, I got it.
Oh, cool. Cool. All right. How do
I
we?
looked at it as times 2 instead of times 1/2, so then I thought the 4 like this.
Ah, gotcha. Gotcha. We feel all right on that? All right. Using these 3 equations. All right. If you want some extra practice, try that. Try working on those. Okay. We got about 2 minutes left.
Yeah.
I wouldn't know where to find that Go video. I was gonna do my dollar bill example. No one wants to try my dollar bill experiment? I don't have $100 bill. I don't have any bills actually.
Yeah, I don't have any bills.
Does any single person have a dollar bill on them? Can you get it out?
Sure. Am I gonna keep it?
Yeah. It's not like a super magician trick. So, what I want you to do, we're gonna test your reaction time. Who had the fastest reaction time in your group?
Not me.
You remember? What was your reaction time? So, can I see that? So, for you to have a good reaction time to catch a dollar bill, you have to have a reaction time of 0.178 seconds.
I'm slow.
Hey, yours is lower. So you should be able to catch it. Who got the dollar?
I'm sure I could have stopped.
I'll get all of that.
You were 20 centimeters.
Oh.
Try again. Try again.
Can I try something? Wait. On brain games? Ready? Yeah.
Ooh.
Oh, wait. I got a better game. Alright.
Oh, yeah.
Alright, so look, I'm gonna drop this and you gotta try to stop it with your head.
Don't do that. He's gonna come away with like a bruise on his forehead.
Oh no, he's got it. Oh, he got it!
You find Julian today?
No, where's it?
One person did.
Yes.
Wait, what?
I found it.
No, where is it at?
Good morning, what about?
Oh, are you joking?
Oreos and mashed potatoes. Different reception.
I'm on fire today. I'm on fire today. You are.
Today's the day.
Except for my water bottle breaking this morning.
Dominic Roder, please come to guide
Have a
phone.
good day.
The following students come to the main office, please. Mikhail Seppi and John Yem to the main office. Also to the main office, Elizabeth Myers. Brandon Johnson, would you come to the attendance office, please? Would the following students come to the main office? Daniel Peeler, Madison Pluta, Lily Robb, Connor Rides, Ryan Schroeder, to the main office, please.
As you came in, I was trying to catch you to do some scrap paper. Did you get a piece of scrap paper? Don't worry about what's on the other side. I love to like save and cut up paper and everything. We're gonna use that for the fake quiz today. My husband took that picture and not worth it. Yes, no. Anytime it says fake up there. But you know, our Quizlet that we did yesterday, that quiz on Monday, I get the fun job of teaching you the metrics today. Awesome. And then where some of you had. I did. So, a friend that is.
Lost the initial. X. X. Your initial must be your type. Yeah. 1 is doable. 2 is doable. Object accelerates at a rate of being. Oh. I not hear anybody.
Hey, Mr. Bowers, I have a question about the free fall video assignment or whatever. So on number 10, I can't figure out like how to solve like how